Next, I just want to give you a graphical interpretation of what an inverse function is. What I've put up here is I've put up two functions, and I'm going to argue that these are inverses of each other. So the first one, we're just going to label it f of x, and the one on the bottom I will label f inverse. Now, the graphical interpretation of the inverse function is that the inverse function should be the mirror image of the original function when reflected over the line y equals x. That's generally what you're looking for if you graph the two functions together. And in fact, the two functions that I've drawn are the purple function is y equals e to the x, and the green function here is y equals ln of x. And we'll get to the natural log function in a minute, but I know most of you know it from algebra and pre-calc, so or you should know it anyway. But as you must be aware, those functions are in fact inverses of each other. What the log function does is it reverses the exponential function. The other thing you can see here is that if you look at the domain of f of x that I've drawn, uh, this has a domain. It's defined everywhere, so its domain is negative infinity to infinity, and its range you can actually see, and of course you know the function, its range is 0 to infinity. Now, if you look at the log function, you can see that its domain, it is only defined for positive numbers. It doesn't have any negative x values. It's not defined for any values on this side of the y-axis. So its domain is actually 0 to infinity, and its range, of course, it goes all the way from down here. And although I know many of you know that the log function flattens out, it actually does grow to infinity if you give it long enough in the x direction. So its range is negative infinity to infinity. And as you can see, these functions do in fact obey the rule that their domain and range, that each one's domain is the other one's range, and vice versa. So we now get to an important rule that gives us the connection between invertible functions and one-to-one functions. And that rule is this: a function is invertible, that is to say it has an inverse, if and only if it is one-to-one. And now that you have the graphical interpretation of inverse functions, you can actually see why. Because let's suppose that I draw this function here. Let's call it, let's use a different color. So this is y equals x squared plus 1. And the question is that function invertible? Well, if the function is supposed to be the mirror image reflected over the line y equals x, just put in that that's y equals x, then what I should have is its mirror image. If I take this point here and reflect it like that, I take this point here and reflect it like that, you can try to convince yourself that this is in fact what's going to happen by drawing it yourself. But basically, the mirror image is going to be this green parabola here. But as you know, this parabola would fail the vertical line test. So now you can kind of see why you can see why a function that's not one-to-one is not invertible, because if it's not one-to-one, then it fails the horizontal line test. So when I flip it over the line y equals x, the result is going to be a function that fails the vertical line test and is therefore not a function. So this is at least one understanding of why a function has to be one-to-one in order to be invertible. Oh, before we leave this topic, I just want to give you a couple little tidbits. So first of all, injective is another name for one-to-one. So we would say a one-to-one function is an injective function, or sometimes we'll refer to that sort of function as an injection. The next fact is a function is one-to-one if and only if it is monotone. Recall that the term monotone or monotonic was a term that we used in connection with increasing and decreasing. We said that a function that was either increasing or decreasing on a particular interval, but not both, is monotone or monotonic. So it's kind of easy to see why. If you look at this purple function, we can see that this is not one-to-one, but why is it not one-to-one? It's not one-to-one because it takes on certain y values on its way down, but then it starts heading back up, therefore circling back on the same y values. If instead the function simply headed downward forever, it would never take on the same y values again, but then it would be a completely decreasing function. It would be a monotone function that happened to be a decreasing function. So essentially we can tell that a function is one-to-one or injective if it is monotone, and therefore the fact that a function is monotone also makes it invertible. I realize that's a huge amount of logic that you have to digest, so don't worry if you don't get that right away. But that's the full story about invertible functions. We're going to return to this topic of what happens if you have a one-to-one function but you need an inverse once we get to the inverses of the trig functions.